So Chapter 8, Hypothesis Testing. The first couple chapters we use descriptive statistics, all right, whenever summarizing data. Now we've moved into inferential statistics. Through Chapter 7, that's where we went over estimating parameters, population, mean, variance, standard deviation, with confidence intervals. This chapter is all about hypothesis testing. Okay, so our main objective is to develop the ability to conduct hypothesis tests for claims made about a population proportion, a population mean, or a population standard deviation. Once you understand the method that we go through for a hypothesis test, it's basically going to be the same for any parameter. It's just going to be, which test statistic are we talking about? Or which formula do I use to do what I need to do? Okay. A couple of examples your book gives on hypothesis tests or a hypothesis that can be tested. The XORT method given by the Genetics and IVF Institute claims that couples can increase the probability of having a baby girl. So that would be their claim. And then there's a method to go through after looking at different studies that would either support that claim or not support that claim. A newspaper cites a PriceGrabber.com survey of 1,631 subjects claims that a majority have heard of Kindle as an ebook reader. It would be pretty hard not to have heard of a Kindle, but I'd probably agree on that one. Then there was one more about health. It's often claimed that the mean body temperature is 98.6 degrees. We can test this claim by using a sample of 106 body temperatures with a mean of 98.2 degrees. All right. There's a nice little caution there. When conducting hypothesis tests as described in this chapter and the following chapters, instead of jumping directly to procedures and calculations, be sure to consider the context of the data, the source of the data, and the sampling method used to obtain the sample data. Okay. All right, which brings us to Section 2. The basics of hypothesis testing. Alright, so the first thing that we're going to go over in this section is how to identify the null hypothesis and the alternate hypothesis from a given claim, and how to express both in symbolic form. Alright, then we'll go over how to calculate a test statistic given a claim and sample data, how to choose the sampling distribution that is relevant. So is it Z? Is it T? Is it chi-square distribution? How to identify the p-value or identify the critical values, and how to state the conclusion about a claim in simple and non-technical terms. There's a chart on this, that last point here, that if you want you can copy down onto your formula sheet. It may help you a little bit, or at least know where it is if you need to go back and look for it. Okay, so what is a hypothesis? I'm sure this isn't the first class where you've seen hypothesis. A hypothesis is a claim or statement about a property of a population. That's what it is regarding statistics. A claim or statement about a property of a population. A hypothesis test is a procedure for testing a claim about a property of a population. So when we actually go through and do the test, that's the procedure for testing a claim about some property, whether it's a proportion, a mean, a variance, a standard deviation of a population. All right, then of course we still have this rule, whatever type of statistics we're looking at. If under a given assumption the probability of a particular observed event is exceptionally small, we conclude that the assumption is probably not correct. All right, and we're going to start off with the null and alternate hypothesis. Okay, so starting with the null hypothesis, that's definitely the most important term that I've covered so far, or that I've mentioned so far. We denote the null hypothesis H sub O. So anytime you see H sub O, we're talking about the null hypothesis. Sometimes I may even just refer to it as H sub O, or I may just refer to it as a null hypothesis. Just know that I'm talking about the same thing. Alright, the null hypothesis is a statement that the value of a population parameter is equal to some claimed value. The null hypothesis is a statement that the value of a population parameter is equal to some claimed value. So if you remember anything about the null hypothesis, I would remember that we're going to denote it H sub O, and it has something else that's very important, some other property. It's that it's equal to. The null hypothesis will always have equal to. Alright, we test the null hypothesis directly in the sense that we assume it is true and reach a conclusion to either reject H sub O or fail to reject H sub O. Notice we don't say that it's either true or false. Either we reject H sub O or we fail to reject H sub O. And so whatever test method we use, we go through and we do all this different stuff, and then that's the conclusion. We're either going to reject H sub O or we're going to fail to reject H sub O. Okay? That's the null hypothesis. Now we have another hypothesis with every claim, and that hypothesis is called the alternate hypothesis. The alternate hypothesis we're going to denote H sub 1. Alright, your book does also say that it can be denoted as H sub A, but that's really not done any longer. So if you see an older study, you may see an H sub A, but more than likely you're just going to see H sub 1. Alright, and that's going to be the statement that the parameter has a value that somehow differs from the null hypothesis. So the alternate hypothesis is the statement that the parameter has a value that somehow differs from the null hypothesis. The symbolic form of the alternate hypothesis must use one of these symbols: less than, greater than, or not equal to. So what's the main things that I would remember about the alternate hypothesis? I'd remember it's denoted H sub 1. So if I say H sub 1, or if I say alternate hypothesis, I'm talking about the same thing. And it must have either a less than symbol, a greater than symbol, or a not equal to symbol. Notice that it will not have an equal to. It will have either less than, greater than, or not equal to. Okay, and so whenever we are given a claim, then we're going to have to somehow be able to take that claim and write down a null hypothesis and an alternate hypothesis. So if you're conducting a study and want to use a hypothesis test to support your claim, the claim must be worded so that it becomes the alternate hypothesis. So if you yourself, and it happens all the time, I get a call or two a year, one who's going back, getting their master's in nursing, and they have to conduct a study, and they're having to do a claim about something, and usually I'll get a call wanting to know if their claim sounds good or if I can help them with their statistics or something like that. So there's a chance if you go and get your master's that you could have to use this with your own study. All right. So here's some steps that you could follow to identify H sub O and H sub 1 or your null and alternate hypothesis. The first thing that you do is you identify the claim. All right. Now, what you want to do whenever you're given a claim is you want to write down the claim and use either equal to, greater than or equal to, less than or equal to, greater than, less than. Use those symbols to write down the claim. Then you need to write down what I like to call the opposite of that. So if you're given a claim that a proportion equals 0.5, the opposite of that would be the proportion is not equal to 0.5. Once you have those two down, the one that has equality is going to be your null hypothesis. The one that does not have equality is going to be your alternate hypothesis. For example, let's look at this claim here. Assume that 100 babies are born to 100 couples treated with the XORT method of gender selection that is claimed to make girls more likely. We observe 58 girls and 100 babies. Write the hypothesis to test the claim with the XORT method. The proportion of girls is greater than 50% that occurs without any treatment. With the XORT method, the proportion of girls is greater than the 50% that occurs without any treatment. So the first thing that you want to write down is, what is their claim? All right, their claim is what? The proportion of girls is greater than the 50% that occurs without any treatment. So how would I write greater than 50%? So that'd be greater than 0.5, right? That's how you write greater than 50%. Now what's the opposite of that? You might be thinking it's just less than, but it's not. It's less than or equal to 0.5. The number itself doesn't change. When you write down the original claim, you're either going to write it as greater than, less than, or equal to. Then you're going to write down the opposite of that. So if it's greater than, the opposite is going to be less than or equal to. If it's less than, the opposite is going to be greater than or equal to. And if it's equals, the opposite is going to be is not equals. Once you have those two written, the one that has equality means the one that is either equals or has an equal to bar under the inequality symbol, under the greater than or less than. This one here is going to be my null hypothesis. And the null hypothesis is always written with equals. So you have P equals 0.5. That's going to be your null hypothesis. The way that you denote that it is the null hypothesis is you put H sub O and then a colon. So H sub O, P is equal to 0.5. The other thing that we have written down, sometimes it's the original claim, sometimes it's not. But the other that we have written down will be our alternate hypothesis. So H sub 1 is going to be P is greater than 0.5. Alright, so we write down the claim using inequality symbols. We write down the opposite of the claim. The one that has equality is the null hypothesis. The other one is the alternate hypothesis. Okay. So let me pull up your text real quick. Alright, so let's see if we can write a null and alternate hypothesis. Let me find some claims for us. Probably have to go down to the problems. Probably down here. Alright, so I could do that on some like these, even though I'm not doing what the directions say. We have some claims right here. Let's look at 26 and let's identify the null and alternate hypothesis. Alright, so for number 26, the original claim, fewer than 20% of M&M candies are green. Okay, we're not worried about the next part. So fewer than 20%, that would be P is less than 0.2. So the opposite of that would be P is greater than or equal to 0.2. The one with equality is my null hypothesis. And the null hypothesis always has equals. So you'll say, okay, H sub O where P equals 0.2. Your alternate hypothesis is going to be P is less than 0.2. All right, let's look at number 27. The original claim, women have heights with a mean equal to 160 centimeters. Again, that's a mean. So how would I write that down? Women have heights with a mean equal to 160 centimeters. So you'd say mean mu equals 160. So the opposite of that would be mu is not equal to 160. The one with equality, that is my null hypothesis. And the other is my alternate hypothesis. Okay? So that's the first part of looking at any claim, is to be able to write down the null and alternate hypothesis. So after you have identified the null and alternate hypothesis, then we need to figure out the significance level. Most of the time with studies, you're going to have a significance level of 0.05 or 0.01. So that's like a 95% confidence level or a 99% confidence level. All right, let's look at this slide here. Select the significance level, alpha, based on the seriousness of a type 1 error. And we'll go over type 1 and type 2 errors in just a little bit. Make alpha small if the consequence of rejecting a true H sub O are severe. The values of 0.05 and 0.01 are very common. Of course, the smaller the significance level, then the more precise, I'm not going to say more correct, but the harder it would be to reject the null hypothesis. All right, and again, significance level says, is the probability that the test statistic will fall in the critical region when the null hypothesis is actually true. All right. This is the same alpha introduced in section 7.2, so the same stuff that we did in chapter 7. Most of the studies that I've looked at have a significance level of 0.05 or 0.01. They could be a little different though. So what type of test statistic are you going to have in your, that's going to relate to your study? I believe these are the formulas that are on your formula sheet just under chapter 8. And depending on what section you're looking at, you'll use different test statistics. And this kind of relates back to chapter 7 as well. When we talked about proportions, it was a Z distribution. If we're talking about a mean, it depends on, do we know the population standard deviation or not? Okay? And so it's going to meet one of these criteria to decide whether it's a T distribution or a Z distribution. If we're talking about the standard deviation or variance, it is a chi-square distribution. And these are the formulas that you use to find your different test statistics. Okay. And again, I believe these are listed on your formula sheet. But you definitely have to use these to work out problems, so it's important you know where they are. So what is a test statistic? The test statistic is a value used in making a decision about the null hypothesis, and is found by converting the sample statistic to a score with the assumption that the null hypothesis is true. So what is the test statistic? It's basically just the statistic that you get that's going to help us figure out, Do we reject the null hypothesis, or do we fail to reject the null hypothesis? Alright, so once we have all of that, once we know the null and alternate hypothesis, once we have figured out the significance level and we've calculated our test statistic, then we have one of two different ways to go. There's a critical value way, and there's a, which is the more classical approach, and there's a p-value way. Most of the time I use the p-value method because it, to me, makes a little more sense, and a lot of times is quicker to figure out your right answer. So that's just the way that I suggest working these, and we'll look at the two different ways. I believe there's a really good table, and it may be in your formula sheet, on trying to decide which way. Let me see if I can find that one. Alright, well, this tells you, this is the same slides that we went through earlier, except it goes and tells you, you know, after you find this, then what does that mean about the claim and all of that. But this is in your textbook. Just kind of goes through what all you have to do to use the p-value method and what all you have to do to use the critical value method. They're about the same until you get down to about right after you find the test statistic. Okay? So after you find the test statistic and the critical values, then you have to either decide, do I want to use p-value method or do I want to use the critical value method? And you don't even have to find the critical values to use the p-value method. But there is a little drawback about the p-value method, is actually how do you find the p-value? And that's going to depend on a couple of different things, and there is another table for that, on how to find the p-value method, how to find the actual p-value. Here's another very, very important thing about these tests. We need to know, is the test a two-tailed test, a left-tailed test, or a right-tailed test? That's very important for finding the critical value or for finding the p-value. So if your H sub 1, which that is your alternate hypothesis, if it has not equals to, then it is a two-tailed test. This is definitely something that's worth writing down. If your alternate hypothesis has not equal to, it is a two-tailed test. So that means that the critical regions are split on the right and the left side. If your alternate hypothesis has less than, it is a left-tailed test. So that means that the critical region is all on the left side. Notice that if you were to look at the graph above, the graph for the left-tailed test looks about twice as big, because it is. If you took those two together and you put them there, those regions would be the same. This one region is the same as both of these two put together. And then if your alternate hypothesis has greater than, it's a right-tailed test. Okay. Now, that's very important when figuring out the critical values or calculating the p-value. I would suggest, when you can, to always use p-value test. just because to me it makes the most sense right away, but it may not to you, so you can use either method. But let's first look at the p-value method. Now, once we completed those first 5 or 6 steps on either method, the critical value method or the p-value method, then we decide which way do we want to go. Again, I lean towards the p-value method. Well, how do you find a p-value? Alright, so the first thing that you have to do to figure out your p-value is figure out, was it left-tailed, right-tailed, or two-tailed? Alright, and we do that by looking at the alternate hypothesis. If the alternate hypothesis has not equal to, then it's two-tailed. If it has less than, we're left-tailed. If it has greater than, we're right-tailed. Alright, so let's say that it was two-tailed. Then, is the test statistic to the left or to the right of the center? So, positive test statistics to the right, negative test statistics to the left of the center. Alright, and so the way you find the p-value is if it's to the left or to the right, which it really doesn't matter as long as you can figure out the correct area. If it's to the left, the p-value is twice the area to the left of the test statistic. Alright. If the p-value is on the right, if the test statistic is on the right of the center, it's twice the area to the right of the test statistic. Okay, so once we know that it's two-tailed, then we know we're going to have a critical region on both sides. So if the test statistic is to the left of the center, that means it's going to be a negative. So let's say our test statistic was right here. So that's our test statistic. If it's on the left, then we take the area, twice the area to the left of the test statistic. If it's on the right, you can still find the area on the right, but remember you have to say 1 minus to find the area on the right, but it's going to be twice that. And that's only if it's two-tailed. Alright, if it's one-tailed, meaning it's either left-tailed or right-tailed, then you actually just take the area to the left of the test statistic or take the area to the right of the test statistic. Now, since you're taking an area, that's the values from the chart, the z-score chart. And whenever you find those, the way that you use the p-value is that you compare that back to the significance level. Alright. A couple of, here's another little caution box. Here's something else that's important. Don't get p-value and the p for proportion. Don't get those mixed up. They're not the same thing. The p-value that's a method of figuring out whether to reject or fail to reject the null hypothesis. The lowercase p, that's just a population proportion. So those are totally different. Alright, so after you find the p-value, what do? How would we use that? We use the p-value with the significance level. If the p-value is less than the significance level, then we will reject the null hypothesis. See right here. If the p-value is less than or equal to alpha, we will reject the null hypothesis. If the p-value is greater than, needs to be a greater than right there, the null hypothesis, if the p-value is greater than the alpha, we fail to reject the null hypothesis. So that is definitely worth writing down and looking at a couple times a day until you remember it.
How did you say that was the second one?
If the p-value is less than or equal to the significance level, reject the null hypothesis. If the p-value is greater than the significance level, fail to reject the null hypothesis. All right, so here's a little example here. With a significance level of alpha equals 0.05 and a p-value 0.0548, we have a p-value that is what? Is 0.0548. Is that greater than or less than 0.05? That's right, it's greater than. So since it's greater than 0.05, we fail to reject the null hypothesis. Now, the other way is the critical value method. Again, the p-value method, to me, as long as you can figure out the p-value, is pretty straightforward. The critical value method is too, but a lot of times you have to draw the graph to be able to see it. And the way that you do the critical value method, if the test statistic is in the critical region, so you have to figure out that critical region, and then if the test statistic is in the critical region, you reject H sub O. If the test statistic is not in the critical region, you fail to reject H sub O. So everything we went over so far has been p-value method. I say everything, but when we get to that one point of we have our test statistic, then we have to decide, are we going to do p method or critical value method? If we choose critical value method, you're going to need to figure out the critical region for whatever your alpha is. And so you you'd have to look at the graph and say for a significance level of, I think, 95%, that critical Z region, if it's right-tailed, I believe that Z is 1.645. So then what you'd have to do is you have to figure out, is your test statistic contained in that critical region, or is it out of that critical region? Your text here has another example. It says if you have a test statistic of 1.60 and a critical region, Z equals 1.645 to infinity, then what we'd want to do is, okay, here's the critical region. A Z of 1.6 is going to be really close, but not in that critical region. That's the test statistic. So since it's not in the critical region, you would fail to reject H sub O. If the z-score is actually in the critical region, like say the z-score would have been 1.7, then 1.7 would definitely be in this area because that's greater than 1.645. So you would reject H sub O. Now looking back at both of these methods though, that's why I always say, you know, if you could just stick with one and learn how to do one method easily, then, you know, why not? And I always tend to lean towards the p-value method. either method, we still have to identify the null and alternate hypothesis. We still have to figure out the significance level by reading whatever the problem says it's going to be. We still have to figure out a statistic, a test statistic, either way. Okay. So let's go back to these slides real quick. All right, and in these slides right here, it was talking about the same study that we looked at before, and they actually figured out the p-hat that you would need to find a test statistic for the proportion. If you look back at the test statistic for a proportion, the formula that you need for a proportion p, notice there's a p-hat and there's a p. P-hat comes from the actual sample that you're looking at. P is the population proportion. So that would come from the null hypothesis. So if we were looking at that same study, the one that had 58 girls and 10 births, no, that's 58 girls and 100 births, then, another typo, that's okay, then p-hat is equal to 0.58. We can calculate the critical test statistic, rather, by saying p-hat minus p over the square root of, now this isn't p-hat and q-hat down here, this is p and q. So if our p that came from our null hypothesis is 0.5, then our q also has to be 0.5. There were 100 births in the study, so that's where they get all of that. So they get a test statistic of 1.60. Okay? So that's how you find a test statistic. You just plug the numbers in and do the arithmetic. All right. So, what are we actually doing? I guess this is more along the lines of the critical region test, but really it's the same thing, whether you use a p-value or the critical value. If the values are in here, the test statistic tends to go to values in here, then you fail to reject the null hypothesis. If your value, whether it's a test statistic or a critical, or a p-value, is in one of these red regions here, that's where you reject the null hypothesis. Now remember, it is important whether it's two-tailed, like this, two-tailed, left-tailed, if you have less than in the alternate hypothesis, or right-tailed, you have greater than in the alternate hypothesis. That does make a difference in finding the p-value. It also makes a difference for your critical region. Because if you have not equal to with the alternate hypothesis, then your critical region has to be split, the left and the right. So if your alpha is 0.1, then this critical region would have 0.05 and this critical region would have 0.05. But if it's left-tailed and your significance is 0.1, then this region has 0.1 area. So that makes a big difference when finding the critical value if you use that method. But if you use the p-value method, just use the table that tells you whether to take twice or take the area to the left or take the area to the right. Okay, and that's what this slide shows, is the same thing that the figure shows in your ebook. So I believe that this is on your formula sheet, so you don't have to worry about copying it down. If it's not, you know, I would copy it down or do whatever you need to do. You can make a copy of it if you want to print it out or whatever. But it'll definitely make your life a lot easier when finding a p-value. A lot of times I don't remember these, even though it is pretty easy to remember. I don't remember. I just look at the table and it tells me what to do. The critical region, that's used for the critical value method. And that's what these next few slides are going through. The critical value separates the critical region from the values of the test statistic that do not lead to rejection of the null hypothesis, which I've already covered. And so I said that if you're using the critical value method, if your test statistic ends up in the critical region, that's where you reject H sub O. If it ends up before the critical region, then you would fail to reject H sub O. These next few slides are doing the exact same thing. They're just telling you how do you decide. And it depends on whether you use the p-value method or the critical region method, or the critical value method, sorry. P-value, you just look at the alpha. That's why I like to use the p-value, because I don't have to worry about where the critical region is. I figure out a p-value, and then I just look at the alpha. When you look at the alpha, if the p-value is greater than the alpha, then what do? You remember? It's from your textbook. If the p-value is greater than, you fail to reject. If it's less than, you reject. Now, how do we actually word what we get? There's a table somewhat similar to this that you want to make sure that you can find in your textbook. Because some of your homework problems, the very last part, if it's like A through D or A through E, it's going to say, how would you word the conclusion in non-technical terms? All right, that table is here in your ebook. It's table 8.3. I don't see the page number, but it's in 8.2, in section 8.2. It's really going to depend. First, you have to see, does your original claim include equality or not? If your original claim does not include equality, then it's going to be one of these two here. See, original claim does not include equality. Original claim does not include equality. If your original claim does include equality, means it has an equal to in it or equals, then use one of these two here. Then, did you reject or fail to reject the null hypothesis? So if you rejected the null hypothesis using either the p-value or critical value method, then we want to use the conclusion for this top here. If you did fail to reject the null hypothesis, use the next one. All right, so once you figure out, you know, does the claim include equality, yes or no, then did you reject or fail to reject, then go over and just use that conclusion. Let's say that the original claim did not include equality and you rejected H sub O. There is sufficient evidence to support the claim that, and then list your original claim. Or there is not sufficient evidence to support the claim that, and then list your original claim. So again, it depends on, does the original claim have equality or does it not? And then once you figure that out, did I reject or fail to reject the null hypothesis? I really like this table here because it kind of is, a little flow chart. It just makes a little more sense. Yes or no, does it contain equality? Then, did you reject or did you fail to reject? Then it tells you how to word the conclusion. Okay. And I can always print something out like this, or if you're watching the video, you can always just take a screenshot and print it out if you wanted to use this table. And this table may be in your notes, in your ebook somewhere. I just didn't see it. Caution: never conclude a hypothesis test with a statement of reject the null hypothesis or fail to reject the null hypothesis. Always make sense of the conclusion with a statement that uses simple, non-technical wording that addresses the original claim. All right, some texts use accept the null hypothesis. We are not proving the null hypothesis. Fail to reject says more correctly that the available evidence is not strong enough to warrant rejection of the null hypothesis.